All right, let's get started with question 1 for the major project. And it says to develop appropriate descriptive statistics to summarize the data. Appropriate is the key word here. So you should have a spreadsheet that looks like this. I do have extra worksheets already prepared for you, but let's start with just your main data set. So I like to start with a filter. Go to data, hit filter. Then we can start to understand what's in our data set. If you click on this, we can see we have people between the ages of 19 and 42. We have males and females. We have people that have invested in real estate. They have the value of investments and so on. Now, if we were to do descriptive statistics, we need to go to data analysis over here in the analysis tool pack. If this is not on your computer, go to File, More, Options, Add-ins, and down here where it says Manage Excel Add-ins, hit Go. And this box should be checked. It's okay if you have other boxes checked, but at least check that first box and hit OK. Now this should work for you, the data analysis, and use descriptive statistics. We'll play around with a few of these others later. So descriptive statistics. Now we want to first select our data. So in the input range, you can either highlight the whole column. What this does is it gives you everything, including the blank spaces at the end, which is fine. That's fine as long as there's not some random character down here at the bottom, which there shouldn't be. So that's fine. You can do it that way. That's typically how I do it. You can also do, if you're at the top, hit Shift Control down arrow. That takes you to the bottom of the data set. It actually takes you to the bottom of the data, at least until you get to a blank space. So let me show you what that means. If I come in here and I tell this, we'll just do this one here, age 28. I'm going to take that out. So now we have a blank cell. If I do Shift Control down arrow, it takes me to that blank cell. So if there's any blank cells in this data set, that's where it's going to take you. So be mindful of that. I'll put that 28 back. All right, so data analysis, descriptive statistics. Okay. I'm going to change this, make sure I have the whole column in there. And then you'll see new worksheet, labels in first row, summary statistics, and 95%. Hit OK. All right. So this gives us some information. It says that our average age is 30. We have, let's see, an age range of 23 with people between the ages of 19 and 42. There's 410 people in the data set. So it does give us some information. I wouldn't present it this way because that's too many points after the decimal. So I would definitely clean it up a bit. Some people use two numbers after the decimal. Some people, especially for age, will just use the whole number. So that's up to you how you want to present it, but just clean it up a bit. And we'll talk more about what each of these are in just a minute. But let's go back to age and take a look at, does that really give us? So really all we're finding out here is that they're about age 30, and we have people between ages 19 and 42. Now, truly, I could see that if I highlight that whole row or whole column, at the bottom of the display in this gray area, you should see average, count, min, max, the sum, if we wanted to know the total of everybody's age. And this count, you'll notice, is 411 instead of 410. That's because it's including the title. It's including this top label. That's why. So if I just highlight the data itself, the numbers, then we're back to 410. So it's giving you pretty much what we found out in the descriptive statistics function. Now, I think it's more intuitive for this one, and this is where we get to the appropriate information to do a pivot table. So if you go to Insert Pivot Table, and here you have your dotted lines all the way around the data. So the whole data set's going to be here, and we want it in a new worksheet. Hit OK. I want to see age. And I don't want the sum of the age. That doesn't tell me anything. So change that value field setting to count. And now we can see we have 410 people in the data set, but we want to break that down by age range or by age. So if you pull both variables to rows and values, then you can see you have people between the ages of 19 and 42. You have 410 people in the data set. And you can also see if you go to data and you filter or sort by largest to smallest here, now we can see, well, the most common age is 43. So 40s would be your most common age, 43, 42, 41. So people in their early 40s is what we're mostly looking at. In fact, that covers, let's see, 126 people of our 410 participants. So that's quite a few. In fact, if we wanted to get a percentage of that, we have 410 people, 126 are between those ages. So if we divide that, we'll see that's 31% of our population, of this sample population, are between the ages of 29 and 32. All right. So that just gives you a little bit more information there as to who's in your data set, specifically for age. Now let's take a look at females and males, so our genders. Now, if I do a descriptive statistics, so go to data, data analysis, descriptive statistics, and I put this column in. Everything else can stay the same and you hit OK. You're going to get an error because this isn't numerical data. We would have to change that so that it's numerical data. Now we'll change it in a bit for one of your other questions, but for this, it just doesn't really make sense because we're going to know if we go back to an actual descriptive statistics, this one was age, but if we're going to do female and male and we code it ones and zeros, we're basically going to see that our range is 1 and our min is 0 and our max is 1. So it's just not going to give us a lot of information. I think with this one, again, the pivot table is going to be better. So we can go over here to our pivot table. I'll go ahead and label this because we'll use it quite often. As long as you click inside of that data or your output, this box pops back up and you can rearrange things. So let's look at gender. Now, if you just click on gender, it's going to show you, okay, for each age, how many males and females do I have? And that's pretty helpful, pretty intuitive, in fact. And if we wanted to look at specific age ranges, you could come up here to age, down, use the down arrow, and we could just say we want, let's go back to that 29, 30, 31, 32 age range. Well, we have 165 people, and this breaks down males and females for us. If we just want to focus on gender, we can just get rid of age altogether by clicking it up here in this pivot table field. So we know we have males and females, but we also want to know how many of each. So let's drag the gender over here, and we'll have count of gender. So now we can see we have 181 females, 229 males, and that's pretty helpful, but I always like to report that in a percentage. So to do that, we know we have 410, put our numbers here, and then you divide. So divide the small number, 181, by the big number, and you get your percentage. You go to home and you can hit percentage, it automatically calculates it for you. Then you can drag this and you see you have 56% male, 44% female in this study. Now you could get pretty creative. Maybe we want to see how many of those folks have kids. So here we have females, yes and no. So there's more females that have children than not. And there's more males that do not have children than those that do. So that too, I think, is interesting. Again, you can just play with this data. Maybe you want to see how many males and females have broadband access. Here we have 112 females that do, but you also have 144 males that do. So both, there's more males and females that have broadband access than those that don't. If we were going to do a percentage of that, maybe we want to do a grand total percentage. So if I do equals 85 plus 69, those are those that do not. You'd also do equals and click on that field plus and click on this field. There we go. So these are the yeses, these are the nos. Again, if I want to put it in as, oops, as percentage, I'll divide this number by 410, our total population or our total sample size. And then we can see 62% of the sample has broadband access and 38% do not. So I think that's really getting to the meat of the matter when we look at descriptive statistics. Now I want to show you something more specific with the descriptive statistics function. It's really going to come into play here for the value of investments and the household income. So these two, that's what we're going to focus on now. If we go to data, we go to data analysis, descriptive statistics, and we're going to look at, let's do value of investments. Everything else can stay the same and hit OK. All right. Now, to make this larger, you can double click. See how my cursor, when I get to the middle between B and C, if I double click that, it will automatically make it the right size. You can also take it and drag that out, and it will bring your columns out to whatever size you want it to be. And you can do that for one column. You can do it for both columns. That gives you a way to make it more visibly appealing. Now, remember, with this, you also want to go to home and you want to format it so you don't have so many numbers after the decimal. So again, I typically do 2 digits after the decimal. We're talking about money here. So most of this will be money, not all of this, but most of this will be money. And with this, so let's see here. I want to look at the mean, which is the average. Median and mode, you know what those are, mean, median, mode. Median and mode are sometimes helpful, but not very often. And then I want to look at my range. So minimum, maximum, range. I don't know why we'd want to look at sum. I mean, this would tell us the total dollar amount of investments for these 410 people. Maybe if we were putting together a portfolio for these 410 people, that would be helpful. But as a general rule, when we're looking at sum for a random sample, it's just not helpful. We have 410 people, so we don't want that with a dollar sign. This is our confidence level. We'll talk more about that in a bit. We'll also talk more about skewness and kurtosis and these other pieces in a bit. But for the most part, the ones with the dollar signs is what we're most concerned about. So for value of investments, this would tell you our min and max. So not everybody's investing. Some people have over 100,000 invested. Again, we have 410 in the data set. And those that invest, their investments range from $0 to $133,400. So that's about it with this value of investments. Again, if you wanted to do a pivot table, you could come over here, look at your value of investments. Here we have it separated by male and female. And this time we're looking at dollar signs, so I'll go ahead and put that here. You can see that males are predominantly investing more money than females. You could also look at that by age. If we want to say age, we don't want the sum of age. But here we have, remember we had used this filter option. So filters are wonderful, but you have to remember to clear them if you're going to include all the information. So clear the filter, come back over here and you can sort this again from biggest to smallest. And then you can see these are the age ranges that have the most invested. So that's interesting. Now we'd need to know how many people are in each of those age ranges to have any sort of, true idea of what's happening. So we want to do a count right there. So it's saying 42 people are 31 years old. Now I double check that. I might have done that wrong, but let's see here. That was 31 years old. So if I come over here and I put 31 years old, and it does say there's 42 people down here at the bottom. So that's helpful. It also can give you the total dollar of investments if we highlight that. And then you can see that sum, 1,294,600. And that's what it's showing you. So I like to double check pivot tables because it's very easy to either leave your filter on or to just have this set up incorrectly and not get the correct output that you're looking for. But that gives you some information then about value of investments. Now what I want to do is one final descriptive statistics for question 1, and that's going to be on household income. So data analysis and descriptive statistics, and then we're going to change this to household income. Okay, so same basic principles here. We have our mean, median, mode, our range, and I already have this one put together with some definitions of what each of these are. So I'm going to unhide some of these columns so you can see it. Now, the mean, again, that's your average. The median, that's the number in the middle. If I put all those numbers on a list, that would be the middle number in the list. The mode is the number that occurs most often. So these two, while they're information, they're just not super helpful. Your standard deviation, I'll get to that in a minute. Let's go down here to range. So that's the lowest number to the highest number. And here we have the lowest number, which is min, the highest number, which is max. So if I do a formula, I say equals the maximum number minus the smallest number. That gives you the range. So that matches. Okay, then the sum, that's the total. If we add everything up, the count, that's how many people are in the sample. Now, the standard error, that's the estimate of accuracy with this sample. So we have 410 people in this sample. If we were trying to generalize this to a larger population, this is telling us that our error would be rather large. In fact, we see that too with the standard deviation and the sample variance. We also see that with kurtosis and skewness. So kurtosis and skewness are specifically looking at normal distribution. And the kurtosis, some people say that's the peakedness. Others say that's the combined weight of the tails. So if you think of your bell curve in a histogram, the way that that bell curve is shaped, if it's normal, it's going to look normal. If it's skewed to the right or the left, it's going to have a tail. And that will let you know if you have any outliers. It will let you know if you just have maybe your data is heavily weighted. For example, in this one, if our data is heavily weighted to younger people or older people, that tail would shift to either the right or the left. Now, if this number, the 7.49, let me actually get rid of some of these extra zeros. If that number, there we go. That's what I'm on, 2 decimals. Okay, so the 7.5, if that number was close to 0, it would be a normal distribution. It's not close to 0, it's 7.5, so that's quite a bit off. If the skewness, and these aren't all dollar signs, by the way, so let's get rid of that. Actually change that to general. There we go. The skewness is looking at if the data is symmetrical. If it's a normal distribution, again, this 2.01 should be 0. If it's between 0.5 as a negative or positive 0.5, it's fairly symmetrical. But this one's 2.01, in which our information says if it's plus or minus 1 or bigger. So if it's a -1 or larger, or a 1, +1 or larger, it's not symmetrical. It's not a normal distribution. Now, people argue that these two are not really a good measurement of if this is a normal distribution or not, because it's heavily influenced by the sample size. So here we have 410. If we had 4,010, these numbers would be different. And maybe we could rely on it a little bit more. But for the most part, skewness and kurtosis is better viewed when we look at it with a histogram. And we can actually see that bell curve. And we can actually see those outliers. So I don't typically pay much attention to that in the descriptive statistics table, with all that said. All right. Okay, so that's about it with that. Now I want to talk about mean and confidence level, because that's going to show up on a different question for you. So I think you get the gist for question one. For question one, we're going to go through the whole data set and do that for each of these variables. We want to know who's in our data set, how many have purchased real estate, how many transactions. Do it for each one for question one. And that takes care of question one.